activity for energy conservation, energy skate park. Law of conservation energy, which states that energy can neither be created nor destroyed. It just changes forms. As the skater is up in the air, at its near maximum point, there we go, something like that. There's always going to be a total amount of energy in the system, and later in the activity, I end up quantifying it to be 100 joules, and it's just arbitrary. So let's just say there's 100 joules total in the system. It's not like it's just going to vanish and go from 100 to 90 total. So there's always 100. It's just like it just gets distributed differently depending on what the person is doing. So the person is at the highest point on the ramp and not moving, then there's going to be zero kinetic. And of course, we're neglecting friction, so zero thermal. So all that's left, the only form of energy that this person has is potential, gravitational potential, because she's up in the air. So all 100 joules, for example, is dedicated to potential. And then as she goes, that's not going to work. As she goes down, she's going to pick up speed and get lower to the ground. So potential is going to decrease because she's getting lower to the ground, and kinetic is going to increase because she's speeding up. Potential depends on how high you are, or at least gravitational. Kinetic depends on how fast you're going. Our potential decreased, our kinetic is increasing. Notice our total is staying the same. All right, and then once she reaches the very bottom of the ramp, potential is going to be at zero because she's at zero height. And she's going to have all 100 joules is going to be dedicated to kinetic. And that makes sense because she's at her fastest speed at the very bottom. And then as she starts heading back up, her height starts increasing. So potential, that kinetic starts to become potential again. And likewise, when you're on a ramp like that, you start to slow down because of gravity. So kinetic starts to decrease. Now we're back up maximum height on the ramp at the top. All 100 joules has been dedicated to potential. There's no kinetic anymore because she's stationary. And then she's going to start heading down, and it's going to redistribute itself again. And you just watch it, and it just goes back and forth and back and forth. At any point, I could stop it, and the sum, the total between these two is always going to be this. And if, again, I quantify it, that would be, say, like it's always going to equal 100 total. Whenever I add friction to it, say, as she's going down the hill, this potential energy is being converted into kinetic, yes, but it's also being converted into thermal. So some of this potential is being lost in the form of thermal and form of heat because of the friction of the skateboard. It's like the heat stays, for at least temporarily, stays within the components and doesn't get used elsewhere. That thermal does not then become potential. It does not then become kinetic, at least for the purpose of this simulation. It stays as thermal. So there's less to be used for kinetic and potential. Say like if you get money, if you get paid every month to do something like, I don't know, cutting grass or something, typical example, babysitting, and you always spend your money on two things. I'm not going to say what those two things might be, but always spend your money on two things. And then say at some point you start saving some of that money. So you take out of your like monthly pay, you take some and you deposit it. So you allocate some of it to your savings. It's like what thermal is, sort of. So that leaves less for you to use, for you to spend between those two things you've been spending your money on. If I stop it, the sum of these three, what would they equal? Yes, that's right, 100 joules. So you added these up, they would equal this, and we're just pretending that it's 100 joules. So there's always a total of 100 at any point because energy is conserved. It doesn't get destroyed, it just changes forms. Okay, and then gradually she's slowing down because of friction, so her kinetic is going to get to zero, and eventually she's going to reach the bottom of the ramp and at height zero, so no potential either. So that means all of it has converted into thermal. That's the main idea, the main concept behind this that I want you guys to get. So like in the hand generator thing, just to know that if you want to get energy out of the bulb in the form of light and heat, you got to put energy in, and it doesn't get lost or destroyed along the way. It just gets transferred in other forms like light and heat, and even heat in the components of the hand generator itself.